Three different objects of masses m1, m2, and m3 are allowed to fall from rest from the same point along different frictionless paths. The speed of the three objects on reaching the ground will be in the ratio of. Okay, so let us try to understand the question. So, this complete playlist will be based on solving questions which are based on ratios. Okay, so what is that? How to solve them? We'll see as we go through the playlist. So, let us assume that there are three bodies here. So, this is body 1. They are dropped from the same point. Okay. Which is as equal as saying they are dropped from the same height. Okay. Now the weight of the body is, the first body is m1, weight of the second body is m2, and weight of the third body is m3. All right. Now what I'm going to do is I'm going to take you through the process in the mathematical way. So let us say the velocity. Let us consider the body for the motion of body, or let us say for the body m1. For the body m1, the body is dropped from rest, right? So here the final initial velocity u will be equal to 0 and it will hit the ground with some velocity v, right? So initial velocity is equal to u, which is equal to 0, and final velocity is equal to v. And what is the distance traveled? See, the distance traveled is the height from which the body is dropped. Let us take that as h. Is it given? No. Okay. So let us take that height as h. And when it hits the ground, right, when it hits the ground, we know that the body will be hitting the ground velocity v, which will be accelerated and not decelerated, which will be accelerated by acceleration due to gravity. Okay. All right. Now, for the first body, let us take the equation of motion. V square minus u square is equal to 2as. All right. Now, what is v square? The final velocity, which is here is v. So we can write that as v square minus u square. What is the initial velocity? It is 0. So we'll write as 0 square is equal to, this is 2 into, what is s? S is the height, right? S is the height, the distance traveled. So the object is dropped from here. It means it will come down to the ground, which means the body has traveled that much distance, which is equal to the height of the place where the body was dropped. Okay. In which case, this becomes 2a into s into h. Now, what is a? See, there are many ways of interpreting the concept here, but what I generally follow is, since the body is dropped, this actually results in increase of velocity, right? Velocity will keep on increasing, which means acceleration due to gravity acts as acceleration and not deceleration here. Okay, so I'll take this as positive g. In which case, what do we have? We have the equation as v square is equal to 2gh. Now, see, 2 and g are constant, right? So, if v square is equal to 2gh, then all what varies is v square is proportional to h. And if you take if you take the power of 1 by 2 on both sides, what do you get? You get that v raised to the 1 raised to v raised to the whole raised to 1 by 2 is v. V is proportional to h raised to 1 by 2, or we can say that v is proportional to root of h, right? So this is the relationship between velocity and height. Now, it can thus be said that the velocity of the object reaching the ground is dependent on only on height, right? So this is something we need to highlight, because it depends only on height. Or otherwise we can say that it is not dependent on any other thing which includes mass, and is independent and is independent of what? And is independent of mass, which means the ratio, right? The ratio will basically be equal to, okay, let me explain that also. See, for m1 the height is h, for m2 the height is h, for m3 the height is h, which means for v1 it is proportional to root of h, for v2 it is proportional to root of h, for v3 also it is proportional to root of h, in which case what is v1 is to v2 is to v3 equal to root of h is to root of h is to root of h, which basically is equal to 1 is to 1 is to 1, which makes the correct answer as option C.